Hey YouTube, I'll be running you through the latest in EzBackend, so let's jump right into it. So first of all, for those who don't know, EzBackend is a backend framework designed for startup founders to bring their product to market faster while being fully customizable. It's a bit similar to Firebase in the sense that once you define the structure of your database, a CRUD API is automatically generated for you, which means that you can immediately start accessing your front end. However, unlike Firebase, EzBackend is fully customizable, meaning that you can program any custom functionality you want into it and it will still work. So when your startup outscales Firebase or any other managed backend as a service and you need the extra custom functionality, you can implement whatever you need just like you would in a normal express.js app. But how does the performance of EzBackend compare with popular alternatives? To test this, we wrote some really basic sample apps, one with EzBackend Postgres, Express SQLized Postgres, and Express Mongoose, and compared the results. All of the code used for benchmarking is available on GitHub, so you can view it at any time you want. Having said that, benchmark speeds are extremely subjective to the type of operation, and also lines of code is very subjective to your code style, so if these are important to your project, make sure to check out the source code and run your own benchmarks on your own system. So without further ado, the EzBackend sample performs 2500 reads per second on my system as compared to 1428 for Express Postgres and 1250 reads per second for Express Mongo, making EzBackend nearly twice as fast as the competition. For writes, EzBackend is not as much faster, only being about 1.5 to 1.8 times faster with 1667 writes per second. And finally, to implement CRUD functionality as well as a login logout system, EzBackend requires 31 lines of code as compared to 147 in Express Mongo and 179 in Express Postgres. So while that translates into 82% less code written to achieve the same functionality, it may not necessarily mean that you'll spend 82% less time. Personally, when developing the samples, the EzBackend samples took me around 20 minutes, whereas the Express Mongo and Express Postgres samples took me about 2 days. So it really depends on the user. So now let's move into the new features. Well, first in the pipeline is EzDeploy, which lets you deploy your EzBackend in one click. EzDeploy is designed for you to build once and scale indefinitely. The idea is that each EzBackend instance is stateless, and when you deploy with EzDeploy, a reverse proxy is used to balance the traffic sent to each EzBackend instance. Furthermore, you can scale your instances as well as create read replicas of your database at the edge, in the same region as your users, thus greatly reducing the latency of requests. There are some caveats though. For example, all database writes have to be performed to the main database, which could result in higher latencies for write requests. We are currently looking into scaling these write operations with sharding as well as write-back caching, but there are no promises on that. And the second caveat is replication lag, because when a read request to a replica occurs at the same time as a write to the main Postgres instance, the information read out may not be fully accurate. However, in scenarios where data accuracy is paramount, EzBackend reads can be configured to read from the main Postgres instance instead. So if you're interested in EzDeploy, make sure to sign up for our open alpha program, link in the description below. The next thing that will be implemented is EzRealtime, which allows your users to listen to database updates with Socket.io. You can currently listen for 3 events: creation, deletion, and updating. So let's say you have an app where you want your users to see every time a new property listing appears. You simply need to listen to the event and you'll be able to update your app in real time. So naturally, you wouldn't want every user to be able to listen to every create, update, and delete request. And for this, we have EzRules. EzRules provides security at the packet and request level. And that means that a moment a read or write occurs, the execution is intercepted and checked against your read-write security rules, depending on whether the request is being initiated from Socket.io or a HTTP request. So you can see in this example, if the user is an admin, he can receive updates on the person database. However, if I switch him over to not an admin, then he is no longer able to receive the updates. And the way this works is really interesting. Basically, it sets a context so that when a request is performed or a packet is being sent or a read or write occurs from the database, what EzBackend does is compare the authentication request as well as the read-write details to determine if the user is allowed to receive that request and throws an error otherwise. So EzRealtime and EzRules are likely to be added very soon. As for EzDeploy, if you want to sign up for early access, the link is in the description, so stay tuned.